Hello students, if your yesterday was good, don't relax, don't be complacent. That means your winning stream has just begun. This is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. Dear friends, a new start, a new chapter, a new session. Now we discuss our master chapter, that is electric current. Dear students, I have introduced the significance of this chapter with respect to its weightage, with respect to its understanding, with respect to its knowledge in our day-to-day life uses. When it comes to the examination pattern, you will have a 1-mark question asked from this chapter, a 2-mark question asked from this chapter, a 5-mark theory and a 5-mark problem constituting 13 marks of the weightage. In your theory exams, there is a 1-marker asked from this master chapter, 2-marker, 5-mark theory question, essentially a derivation, 5-mark problem, 34th problem in your question paper, always from this chapter. 13 marks is the constituted weightage, dear friends. So lots of significance. And when it comes to your practicals, there are 8 experiments, 8 circuit-based experiments which follow up the concepts of electric current. And what more, my daily life activities gravitate around the chapter called electric current. Imagine for 10 minutes a world without electricity, no luxuries, no entertainment, no communication, no work. It becomes a blind life. The minute I get up from my bed to the second I go to sleep, all my activities will be pivoting around a concept called current, power, and that is the significance of this chapter. Therefore, it becomes very essential for us, trivially important for us to understand the concepts of what we highlightingly define as electric current. So in my first session today, I will make you all familiar with the word current. I will make you all physically understand the meaning of a quantity called electric current. We will write down the mathematical definition of something called current, and finally understand the consequences of electric current. So now I start discussing the master chapter for you all. As shown in my slide, there is a beautiful bulb which is glowing with maximum intensity. I want you all to be as intense as this bulb when I am discussing this chapter. Tumba ಪ್ರಾಮುಖ್ಯತೆ ಇರೋ ಪಾಠ ಇದಾಗಿದೆ. ನಾವು ಜೀವನದ ಪ್ರತಿ ಹೆಜ್ಜೆಯಲ್ಲೂ ಬಳಸುವಂಥ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಗಿರಬಹುದು, ಡಿವೈಸ್ಗಳಾಗಿರಬಹುದು, ನಮ್ಮ ಪ್ರತಿಯೊಂದು ಆಕ್ಟಿವಿಟಿ ಆಗಿರಬಹುದು, ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟನ್ನ ಫಾಲೋ ಮಾಡುತ್ತೆ. ಆದ್ದರಿಂದ ಈ ಪಾಠನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ತುಂಬ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿದೆ. My dear students, the word electric current is a very familiar term that we use quite often. Electric current, current ಹೋಯ್ತು, current ಬಂತು, fan on ಆಯಿತು, television on ಆಯಿತು. Therefore, the word current is a very basic term that we use umpty number of times in our daily life activities. The word current actually has its origin from Latin, where in Latin we use something called curie, and this word curie is to flow, or which is denoting some motion. The word curie refers to flow. The word curie means some motion, and current is taken from this Latin word curie, to flow or to move. Now students, understanding the physical meaning of the word electric current. Your textbook says the flow of curie, flow of what? Electric charges in a conductor constitutes electric current. A beautiful statement. Flow of electric charges. Have I discussed anything about electric charge? Very much yes. In my first chapter, where I told if there is no charge, there is no electrical effect, beautifully justified here. The flow of electric charges, where in a conductor constitutes electric current. If electric charges flow in a conductor, there is constitution of electric current. Now, what are these conductors? We have evidently studied two types of materials, conductors and insulators. Yen conductor andre, they allow the flow of charges. Insulators, no flow of charges. But what is the basic physical difference? Conductor has abundance of free electrons. ದಯವಿಟ್ಟು ಗಮನಿಸಿ, free electrons. In a conductor, there is large number of free electrons, and the motion of these electrons generate electric current. But what is happening in an insulator? Electrons, charges ide, but they are localized. What do you mean by localized? They don't move. Therefore, conduction does not happen in an insulator. Please know, students, in a conductor, there are free charge carriers, free electrons, which actually help in conduction. But in an insulator, there are localized, immobile electrons which do not participate in conduction. But in both these materials, atoms are fixed, alva. in their respective lattice, atoms are fixed. The only thing which moves is free electrons. So dear students, the basic definition of current says flow of electric charges in a conductor. Electric charges flowing in a conductor constitute electric current. Which are those electric charges? Mobile free electrons. But I have a small discrepancy. I cannot accept the entire statement here as the key word is missing. Then what is the actual definition of current? How do I properly define current? I'll give you a very good example. If I need to walk 2 steps from here, I require some energy. More farther distance, more energy. In the similar way, if electrons have to flow, concept of energy has to pitch in, and that energy is with respect to potential. So how do I properly understand electric current? So my dear students, I will consider a conductor. For example, a aluminium wire, manganese, copper, ಯಾವುದೇ ಒಂದು ಕಂಡಕ್ಟರ್ನ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. And there are free electrons inside this conductor. Electrons which participate in conduction. Now I will connect this conductor to a battery. Very important. I am connecting the conductor to a battery. Source, energy device ಅಂತ ಕರಿತೀವಿ. So the conductor which has large number of free electrons is connected to a battery. The longer line indicates the positive of the battery and the smaller line indicates the negative of the battery. ಈ ಕಂಡಕ್ಟರ್ನ ಏನು ಮಾಡಿದ್ದೀನಿ? ಒಂದು ಬ್ಯಾಟರಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಎನರ್ಜಿ ಸೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಎನರ್ಜಿ ಡಿವೈಸ್ ಅಂತ ಕರಿತೀವಿ. The longer line is indicating the positive of the battery. The negative is indicated by the smaller line. Positive means this end is maintained at a higher potential and this end is maintained at a negative, lower potential. Positive of the battery is maintained at a higher potential and negative at a lower potential. My dear friends, this is an ideology. Actually, this might not happen, but it is a convention. It is a theory that I follow. Now, the moment I switch on the battery, there is an electric field established. ಏನಾಗುತ್ತೆ? ಬ್ಯಾಟ್ರಿನ ಸ್ವಿಚ್ ಆನ್ ಮಾಡ್ತಿದ್ದಂಗೆ, the moment the battery, the energy source is switched on, what happens? There is an electric field created due to which there is some potential. So from where am I getting that potential? Because of this electric field. Now I say, this end of the conductor is at zero potential, and this end of the conductor is at V potential, some V potential. The moment I switch on the battery, electric field is created. As an impact of the electric field, some potential is applied. This end of the conductor is maintained at zero potential. This end is maintained at V potential. Now potential is applied, and you studied, the moment there is potential, charges have to flow, electron has to flow, and we knew now the electron starts moving in a direction opposite to the direction of this electric field. Very definition of potential we told. The charge has to move opposite to the direction of the electric field. See, a beautiful phenomenon. Illi zero potential ide. Illi V potential ide. Electrons are moving with certain potential difference. And if this word potential difference is not mentioned, then the definition of current becomes incomplete. So, what is electric current, students? It is the flow of electric charges from one end of a conductor to the other end with a zero or certain potential difference. Electrons here move from a region of 0 to a potential V. So there is potential difference causing the motion of these electrons. Now, how do I come to know that this motion is reflecting as electric current? What is this battery doing? Many a times it is a wrong conception that the battery provides charges for conduction. No. ದಯವಿಟ್ಟು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾವುದೇ ಬ್ಯಾಟ್ರಿ DC ಸೋರ್ಸ್ ಇಲ್ಲಿ charges provide ಮಾಡಲ್ಲ. Then what will it provide? It will provide energy for the charges to move. The later part I will discuss in detail about batteries and cells. Now just know, a battery just provides energy for a charge to move in the circuit. Therefore, it is a storage device. It is an energy device, an energy source. Now these electrons are carrying some energy, alwa? Connect this to a fan. Immediately the fan operates. That energy, that electricity constituted is converted in the form of electrical energy. Connect this to a television, switches on, so you can see very clearly electric current is performing in the way of electrical energy. So this is the ideology as to how electric current is constituted. ದಯವಿಟ್ಟು higher risk ತಗೋಬೇಡಿ, then you will suffer severe consequences. Let us refrain only to fans, fridge and televisions. So how do we properly define electric current? It is the flow of electric charges from one end of a conductor to the other end. Essentially what has to be? A potential difference between these two ends. If there is no potential difference, then there is no constitution or flow of charges. Therefore, we told, just to recap, electric current is taken from the Latin word curie, where curie refers to flow or to move. Conductors, large number of free electrons which are mobile, which move. Insulators, localized electrons which do not participate in conduction. So what is actually electric current? Flow of electric charges in a conductor from one end to another with a certain potential difference. No potential difference, no flow of charges. No flow of charges, no current, as simple as that. Now, coming to the mathematical meaning, mathematical definition, understanding of current, we say it is defined as the rate of flow of electric charges. ಯಾವಾಗ ರೇಟ್ ಅನ್ನೋ ಪದನ ಉಪಯೋಗಿಸ್ತೀರಾ? Somewhere when it is associated with time. So rate of flow of electric charges through any section of a conductor, again with a certain potential difference. ಮತ್ ಪುನಃ ನೋಡಿ ಎಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿದೆ. Mathematics in bandaga with reference to some constraint. Which is the constraint? It is time. It is rate of flow of charges. Andre, I'll consider this section of the conductor. E part of the conductor na consider martini. I assume Q is the charge which flows through this section, E sectionally, in a time interval T. Q is the charge flowing through this section in a time interval T, essentially with some potential difference. Then the current constituted here, I is Q divided by T. Very basic definition of current. Rate of flow of charges. I equals Q divided by T. And therefore, if a charge Q crosses any section of a conductor in a time T, I showed, current is defined as total charge flowing over total time taken, or I equals Q divided by T. And this current is always called strength of the current or steady current. Steady andreno, there is no sudden variations. The strength of the current is stable, doesn't change magnitude wise by large variations. Idu strength of the current anta karitive, steady current anta karitive. Example kodbahuda? Pen torch. Whatever electrical energy is spent by a pen torch, torch nodirtira manenalli, that gives you steady current. So current is total charge flowing divided by total time taken. I is Q divided by T. Steady strength of the current does not vary too much. ಹಾಗಿದ್ಮೇಲೆ non-steady current ಅಂತಿದೆಯಾ? ಇದೆ. Very clearly you see a beautiful picture. Thunder, lightning. What happens during lightning? There is sudden discharge of electric charges by huge variation of current. Suddenly electric charges are dispersed. That is called non-steady current. Andre, if I consider the same section of the conductor, Q1 is the charge flowing through that section at time t1. Q2 is the charge flowing at time t2. Different intervals of time, the magnitude of the charge flowing through that section varies. T1 ಆಗಿದ್ದಾಗ there may be 2 coulomb of charge flowing. In a time interval T2, there may be 10 coulomb. Time interval T3, 20 coulombs. So the magnitude of the charge that flows through that section varies with the time. So I have said, if delta Q change, delta andrenu, it represents change in what? Charges. Delta Q is the amount of charges, magnitude of charge which flows through this section between the time intervals t and t plus delta t. T plus delta t andre at next successive intervals of time, 2 seconds, 3 seconds, 4 seconds, magnitude of charge entering is varying. Therefore current is limit delta t tends to 0, delta q divided by delta t. And the moment you write this limit delta, it is an instantaneous value. Andre, at that instant of time, t1 ಆಗಿದ್ದಾಗ charge is q1. When the time is t2, charge is q2. At those respective instant of times, which can also be written as dq by dt, and therefore this current is called instantaneous current. So steady current I is q by t. Gamansi, delta q by delta t bardilla. Bardidre, it would have represented changes. And if it was a change, it is not steady current. Magnitude varies. But here, very beautifully, it is dq by dt. Essentially, change in the magnitude of the charge with respect to time. Therefore, this is called non-steady. Magnitude is varying with respect to time, and it is called instantaneous current. So mathematically, how did we define current? It is total charge flowing divided by total time taken. Now, going to the consequences. The SI unit of measuring the strength of the electric current is ampere. Practicals, Y1 al kelbodu. The practical unit, the SI unit which measures electric current is ampere. Charge, coulomb. Current, ampere. Potential, voltage. I've clearly told in the first section, part A, one of the questions will be to write the SI unit of a physical quantity. Dear students, you should tip-tonguingly know at the tip of your tongue the SI units. For current, it is ampere. Now for me to discuss the nature of current. Is current a scalar or a vector? Slidely, I'm writing that current is a scalar quantity. Quite interesting, no? See, I say there is a wire, 5 coulomb charges flows due east in this wire. ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗ್ತಿದೆ? 5 ಕೂಲಮ್. ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸಿಕ್ತು. ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿದೆ? ಈಸ್ಟ್ ಅಲ್ಲಿ. ಡೈರೆಕ್ಷನ್ ಇದೆ. Then why do we say that current is a scalar? Is it wrongly written? No. First PUC vector algebra says it is not sufficient for a quantity, even though it has magnitude and direction, to be called as a vector. Magnitude ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ ಇದ್ ಮಾತ್ರಕ್ಕೆ ಯಾವುದೇ ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿನ ವೆಕ್ಟರ್ ಅಂತ ಹೇಳೋದಿಲ್ಲ. ದೆನ್ ವಾಟ್ ಈಸ್ ದ ನೆಸೆಸರಿ ಕಂಡೀಷನ್? ಇಟ್ ಹ್ಯಾಸ್ ಟು ಒಬೇ ಒನ್ ಆಫ್ ದ ಲಾಸ್ ಆಫ್ ವೆಕ್ಟರ್ ಅಡಿಷನ್. ಟ್ರಯಾಂಗಲ್ ಲಾ ಅಂತ ಓದಿದ್ದೀರಾ, ಪ್ಯಾರಲೋಗ್ರಾಮ್ ಲಾ ಓದಿದ್ದೀರಾ, ಪಾಲಿಗನಲ್ ಲಾ ಓದಿರ್ತೀರಾ. You may have studied the triangle law, the parallelogram law, the polygonal law. It has to obey one of these laws in order to be called as a vector. But current does not obey the laws of vector addition. Such quantities, even though it has magnitude, even though it has direction, but violating the laws of vector addition, they are called as tensors. A third type of quantity called tensor. But since you don't study about tensors, now we treat current to be a scalar. So ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು ಇದ್ದು ಡೈರೆಕ್ಷನ್ನು ಇದ್ದು ಕರೆಂಟನ್ನ ನಾವು ವೆಕ್ಟರ್ ಅಂತ ಕರೆಯಲ್ಲ. ಯಾಕೆ? ಇಟ್ ಡಸ್ ನಾಟ್ ಒಬೇ ದ ಲಾ ಆಫ್ ವೆಕ್ಟರ್ ಅಡಿಷನ್. ಹಾಗಿದ್ಮೇಲೆ ಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿ ಏನಂತ ಕರಿತೀವಿ? ಟೆನ್ಸರ್ ಅಂತ ಕರಿತೀವಿ. ಬಟ್ ನೀವು ಟೆನ್ಸರ್ಸ್ ಬಗ್ಗೆ ಓದ್ರಿಲ್ಲ ಆಗಿರೋದ್ರಿಂದ ಐ ರಿಫ್ರೇನ್ ಆ್ಯಂಡ್ ಸೇ ಕರೆಂಟ್ ಈಸ್ ಅ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ. ಪ್ಲೀಸ್ ಟು ಕೀಪ್ ಇಟ್ ಇನ್ ಮೈಂಡ್. Current which flows through a conductor for a short period of time. How short? Until the existence of electric field. Electric field illa andre potential illa. Potential illa andre there is no flow of charges. If there is no flow of charges, there is no current. So such current is called transient current. Transient. For a short period of time. How short? Only until the existence of electric field. Such a current is called transient current. One more questions. In conductors, free electrons constitutes electric current. Name the charge carriers in conductors ಅಂತ one mark ಕೇಳ್ತಾರೆ. It is always free electrons. Current in a conductor is due to free electrons. Semiconductors you will study. It is both due to electrons and holes. Holes ಅಂದ್ರೆ positive vacancies ಅಂತ ಕರಿತೀವಿ. In your semiconductors you will understand. Now know, in a semiconductor, due to partial conduction that happens due to electrons and holes. Then what about a gas? Ionization, ions. There has to be positive as well as negative ions. Copper sulfate, Cu2 plus SO4 minus, both positive and negative. So positive and negative ions responsible for ionization. So these are the few introductory concepts I wanted to make you all familiar with in my session 1. So what did we study? Current. What is current? Flow of charges. Where? Conductor. What should be their potential difference? Mathematically, rate of flow of charges. I equals Q by T. Steady and non-steady. SI unit, ampere. What type of physical quantity? Scalar. Why, irrespective of having magnitude and direction, it does not obey the laws of vector addition? Transient current, current existing as long as the electric field exists for a short period of time. Conductors, charge carriers are free electrons. Semiconductors, electrons and holes, liquid, positive and negative ions. I hope I have made the introductory class very, very useful for you all. Have a recapitulation before we jump into our proper concepts in the next session. Until then, stay fit, stay tuned. Thank you.